Welcome to the series lectures on analog electronics, course code EE311T. This is the third lecture of unit first. In the previous lecture, we discussed about the introduction to electronics, about power supply and basics about the rectifiers. In this third lecture, we will study about the average or DC voltage and load current of half-wave rectifier, about its efficiency, its RMS values of load current and load voltage, output frequency, ripple factor and transformer utilization factor. As you know that a rectifier is a device which converts an AC signal, whether it will be voltage or current, into DC signal. Now we'll find the average or DC values of output voltage and load current. Here you can see there are two figures below. The first one is output voltage of half-wave rectifier, as we have discussed earlier, and the load current waveform of half-wave rectifier. Mathematically, it may be expressed as it is a sinusoidal signal. So V naught is equal to Vm sin omega t for 0 is less or equal to omega t less or equal to pi, and V naught is equal to 0 for pi is less or equal to omega t is less or equal to 2 pi. This is about the first figure, that is the output voltage. Same in case of this output current, that is I naught, that means output current is equal to Im sin omega t for 0 is less or equal to omega t is less or equal to pi, and I naught is equal to 0 for pi is less or equal to omega t is less or equal to 2 pi. Now we'll find the average or DC value of output voltage, which is expressed as V average or VDC. It is equal to area under the curve over the full cycle divided by base. As you can see that area is equal to integral of 0 to pi V naught d omega t. Putting the values of V naught in this expression between the limits 0 to 2 pi. Here it becomes two cases. V naught is equal to Vm sin omega t for 0 from 0 to pi, and again V naught is equal to 0 for pi less or equal to omega t less or equal to 2 pi. From this equation, if we integrate this equation, the area becomes twice Vm. So we got the result about area. Now we have to find the VDC or V average. As you know that VDC is equal to area under the curve over the full cycle divided by base. So our area is twice Vm. That means VDC is equal to twice Vm by base. Base is 2 pi. So VDC is equal to Vm by pi, or 0.318 times V maximum. Hence the DC value is 31.8% of its maximum AC input voltage. Similarly, average or DC value of load current can be found as I average, that means IDC. It is equal to VDC by load resistance RL. As we know that VDC is equal to Vm by pi. Therefore, IDC is equal to Vm by pi RL. So IDC, we can write that IDC is equal to I max by pi, or it is 0.318 times I max. In the above calculation, we have assumed that diode resistance in forward bias is 0. That means the forward resistance of the diode is 0. If the forward resistance RF is taken into account, then the expression for VDC and IDC are VDC is equal to Vm by pi minus IDC into RF. This is for VDC, that means average voltage. And about average current, the equation becomes IDC is equal to V max by pi RL plus RF. This is when we are taking forward resistance into account. Now coming towards the RMS values of load current and load voltage of half wave rectifier. The RMS value of the current flowing through the diode or the load resistance is expressed as I square RMS is equal to 1 by 2 pi integration 0 to 2 pi I L square d omega t, or you can write as I RMS is equal 1 by 2 pi 0 to pi I square max sine square omega t d omega t plus integrate pi to 2 pi 0 into d omega t, where IL is equal to Im sine omega t 0 less or equal to omega t less or equal to pi, and IL is equal to 0 for pi less or equal to omega t less or equal to 2 pi. Solving this equation, our RMS value of load current is Im by 2. That means IRMS is equal to Im by 2. This is the equation when we assume that the forward resistance is 0. If the diode is assumed to be having the forward resistance of RF ohms and the reverse resistance is infinity, then the peak value of current flowing through the diode or the load resistance is given as I max is equal to V max divided by RF plus RL. Now this is the equation for RMS value of load current. Now load voltage or output voltage. As you know that VRMS is equal to IRMS into RL. Simply V is equal to IR. That means VRMS is equal to IRMS into RL. So VRMS instead of IRMS we can write that Im by 2 into RL. This is the equation for load voltage or output voltage, or in other words we can write as VRMS is equal to V max by 2 or Vm by 2. So our other equation becomes VRMS is equal to Vm by 2. If the forward resistance is taken into account, then VRMS is equal to IRMS into RL. That makes V max divided by twice RF plus RL into RL. This gives the answer VRMS is equal to V max by 2. In both cases, VRMS terms is equal to V max by 2. This is the other way of solving for load voltage. Now power. As you know that power is equal to P is equal to I square R. Now we have to find about DC power and AC power. P DC is equal to I square DC into RL, and AC power is equal to PAC. PAC is equal to I square RMS into RF plus RL. So from these two equations we can get the expression for DC power and AC power. Now efficiency. What do we mean by efficiency? Efficiency is defined as the ratio of DC output power and AC input power. So efficiency of half wave rectifier can be expressed as eta is equal to DC power, DC output power by AC input power. Solving this equation, the maximum possible efficiency of a half wave rectifier comes out to be 40.6%. Now, output frequency, ripple factor, transformer utilization factor of a half wave rectifier. Output frequency. The output frequency is same as input frequency, so it can be given as F out is equal to F in. Ripple factor. What do we mean by ripple factor? The output voltage or current of the half wave rectifier contains two components, namely DC component and AC component. The AC component is undesirable and accounts for pulsations in the rectifier output. The AC components are known as ripples. Therefore, the effectiveness of the rectifier depends on the magnitude of ripple in the output. Smaller the ripples, effective is the rectifier. So, the ratio of RMS value of AC component to the DC component in the rectifier output is known as ripple factor. Mathematically, ripple factor is given as gamma, or simply R, that is gamma is equal to RMS value of AC component of the output voltage or current to DC value of output voltage. For solving for this ripple factor, the expression becomes gamma is equal to root of IRMS by IDC whole square minus 1. This is the general expression for ripple factor. So now we can calculate the ripple factor of half wave rectifier. As you know that IRMS is equal to Im by 2 and sorry, IRMS is equal to Im by 2 and IDC is equal to Im by pi. Using these values in the above equation, that means the expression given above for ripple factor, the ripple factor of the half wave comes out to be 1.21. Transformer utilization factor. The factor which indicates how much is the utilization of the transformer in the circuit is called as transformer utilization factor. The transformer utilization factor is defined as the ratio of DC power delivered to the load to the AC power rating of the transformer. While calculating the AC power rating, it's necessary to consider RMS values of AC voltage and current. The transformer utilization factor for half wave rectifier can be obtained as AC power rating of the transformer is equal to Vrms into Irms. Now we know the values of Vrms and Irms. That is, Vrms is equal to Vm by root 2 and Irms is equal to I max by 2. So the expression comes out to be Vm Im by twice root 2. Now one thing you should remember here is the secondary voltage is purely sinusoidal, hence its RMS value is 1 by root 2 times the maximum, while the current is half sinusoidal, hence the RMS value is 1 by 2 times its maximum. So DC power delivered to the load is equal to I DC square into RL, that is instead of I DC we can write Im by pi, that means Im by pi whole square into RL. Now as you know that the transformer utilization factor is DC power delivered to the load to AC power ratings of the transformer. If we solve this, the TUF of half wave rectifier is 0.286, neglecting its forward resistance RF. This is the end of the third lecture. Thank you so much.